Day 3 of semester 2 final. Okay, we're getting to the parts where we're combining like terms, factoring, all of that fun stuff. Okay, so starting with simplifying expressions. When we simplify, we want to know what operation's being used. So what operation's being used on 51? We got this guy in there. It's addition. So does addition mean foiling? No. Okay, what does addition mean? Combining like terms. Okay, so really, do we need these parentheses in there? No. So you can think of that we don't have them in there, or you can rewrite it so you don't have to look at them. Okay, so if I rewrite everything I have left, now we just want to combine like terms. But how do we want to write our answer? Right, greatest degree all the way to the least degree. So what's our greatest degree? Yep, that third power. Does it have any like terms with it? No. So we have 6n to the third. What would be next? Yep, and if it helps, once you use something, cross it out. So I have 6n to the second. Does it have a like term? No. So we have plus 6n to the second. What do I have next? Yep, we have like terms here. Add them together, we get 8n. Once you have combined all like terms, you're done. Okay? Looking at 52, how does it change now? It's subtraction. What do we have to remember to do with subtraction? Right, change the signs of the second. So it becomes minus 6 and plus 6x. So I'm going to rewrite that. First one stays the same, 5x plus 4, and then we have minus 6, and then plus 6x. So we switch the signs of the second quantity. Now what? Yep, same thing, combine like terms. What's the highest degree? Yep, that x. So we have 5x and 6x combined. We have 11x. And then we have our constants. We have 4 minus 6, negative 2. So we have 11x minus 2. So making sure you see what operation's being used and then how to use it. Move on to 53. What operation's being used now? We did add, subtract. Now what's happening? Multiplying, distributing. Okay, so on 53, what do we do with this 8x? Distribute to both. So we have 8x times 7x. 56x squared, right? 56x squared. And then take that same thing, 8x times 1, 8x. You always want to check if it's in simplest form and you have everything combined. Are we good? Yes. Okay. Same thing with 54. Distribute 3b to the second times 2b. So we have 6, and then how many b's? B to the third. And then we have 3b to the second times 2. And that's just 6b to the second. Do we have any like terms? Nope. Okay. What about when we get to 55 and 56? What? Yep, FOIL. So take everything one at a time. N times 6n is what? 6n to the second. And now n times 6, 6n. And then 4 times 6n. And then 4 times 6. All right, when we get to this point, what do we have to check for? Like terms. Okay, does our highest power have any like terms? No. So we keep that one. And then we have 6n and 24n. Add those together, we get 30n. And then we have our constant, 24. Okay. To look for. I want to look at number 57 because it's a little different. Okay, what does that mean? We have 4x plus 8 all to the second power. Yep, write the same thing. So we're going to rewrite. So we have 4x plus 8 times itself 4x plus 8. So this doesn't mean distribute that negative 2 like we were, okay, because it's addition inside. So we have to think multiplying it by itself. So if we do that, now we can FOIL. 4x times 4x is 16, how many x's? Squared. Then we have 4x times 8, 32x. And we have 8 times 4x. And then we have 8 times 8. And then what do you always have to check for? Like terms. Our highest power stays. What about the x's? Combine 64x. And then we have our constant 64. If you have a quantity written to the second power to however many powers, you have to write it twice. Okay. Let's look at 59 before we move on. How does this one change? It's just more. It's the same thing, it just has more terms. Okay, so we're going to distribute each term. So we have 3x times 4x squared, which is 12x to the third. Biggest part in this one is staying organized. Okay. Then we have 3x times 2x, 3x times negative 8. Now do the same thing with the negative 5. Negative 5 times 4x squared. Then we have negative 5 times 2x. And then we have negative 5 times negative 8. Okay, what do we do when we get to this point here? Combine like terms. Start with your biggest power, which we have x to the third. Does it have any like terms? No. Next highest, 2. And then we have our x's. 6x minus 24x is, thank you. Let's back up a little bit. Okay, 6x to the second, how does that change? Now does it have a like term? Yes. Add those together, you get, yep. Now our x's, negative 24x minus 10x, negative 34x, and then we have our constant, 40. A biggest part on that problem is staying organized. Okay, so once you use something, get rid of it so you don't have to look at a bunch of stuff. Okay, any other questions on those properties? Now we're getting to the factoring. Okay. Make sure you read the directions. Factor out the common factor. What does common factor mean? Huh? What does common factor mean? What goes into both? What each thing has in common. Okay, so what can we take out of 60? Problem 60. What do they all three have in common? A 2. Do they have anything else in common? No. So now we're going to take a 2 out of everything. By taking it out, it means dividing. So I have negative, we're looking at this first one, negative 12 divided by 2 is negative 6. And did anything happen to the v squared? No, so it stays. Do that to every term. Negative 2 divided by 2, 1. And then we still have the v on the inside. And then negative 12 divided by 2, negative 6. Check to make sure you factored completely. Okay, is there anything else we can take out of that inside part? No, so we're good. So this is your final answer. let's look at 61. What do those two have in common? They have an x in common. Good. 8. Okay, let's start with that. What do I have left from that 64x squared? 8x. And then what left from the 56x? 7. Double check, is it factored completely? Yes. By what I mean, can I take anything else out of our parentheses? That's what I mean by factored completely. Okay. Let's look at 62. Now this has a lot going on. Take it one at a time. Let's look at the numbers. What number can I take out of all three of those? 6. Good. Now look at the x's. Why just x? Yep, you want to take the lowest. So we have 2, 2, and 1. So we want to take the lowest. And now the y's, we have 6, 4, and 4. 4. Yep. So now take each term one at a time. 6 divided by 6. 1. How many x's are going to be left? 1. How many y's are going to be left? 2. Yep. Remember you're subtracting as exponents. So we have 2 minus 1 is 1, and then we have 6 minus 4 is 2. Move on to the 24. 24 divided by 6. 4. How many x's? How many y's? None. 60 divided by 6. 10. How many x's? How many y's? None. So we're done. Yep. So take everything one at a time on those. Let's move on to these. What does it mean by factor completely? I've kind of been saying it. What does it mean? Think factoring in simplest form. Okay, we want everything simplified to its smallest form. So when we have trinomials now, what does trinomial mean first? 3 terms. Okay, we have 3 terms. So what do we look for now? First, always see if you can take something out. Can we take anything out of those 3? No. What do we do next? What multiplies to something and adds up to something? So what multiplies to 16 and adds up to -8? What do you think? 4 and 4? Can they both stay positive? Why not?
Because
right, it's -8, so what do we need to do? They both need to be negative. Yep. What do I do from here? I have my 2 factors here. How do I write my answer? X minus 4, x minus 4. We don't have a leading coefficient here that we have to worry about, so we can just write our answer. Okay. If you wanted to go farther, how could I write that? Since they're the same. Yep. You won't have to do that, but if you wanted to. Okay. Looking at number 64, what was step 1? Take anything out. Can we take something out? 2. Yep. Always see if you can get rid of that leading coefficient. In this case, we can. So if I take a 2 out, what's left? M squared plus 10m plus 16. Okay. Does this mean we're done? No. We got to factor completely, so we want to keep factoring this inside part. Okay. We're going to keep the 2. What was step 3 on your... What multiplies and what adds? So what multiplies to 16 and adds up to 10? 2 and 8. Do I have to change either of them? No. How do I write that as my answer? M plus 2, M plus 8. And remember, we keep that 2 in there. How could you check if you got it right if you wanted to? Factor it back in. Distribute it all back out. Yep. So this here is our final answer. That is factored completely. Because if you look at each set, you can't do anything more to all three of those. Next. So keep following those same 3 steps. What's step 1? Take anything out. What can we take out? 3 and V. Yep. So now, what do we have left on the inside? V plus 4. Is that factored completely? Yes, it is. Yep. Okay. 66. What's step 1? Take anything out. Can we take something out? No. What's step 2? Is there a leading coefficient? Yes. What do we have to do to that leading coefficient? Yep. Take 3 times 32. What's 3 times 32? So our new C is 96. What was step 3? Yep, what multiplies to 96 and adds up to negative 20? 12 and 8. Can they both stay positive? No, what needs to change? Both have to change. Good. Okay. Since we had a leading coefficient, what are we going to do when we get to this step of rewriting? We got to keep the leading coefficient. Remember, what happens to these two in this one? Do you remember? So remember, we're going to keep our leading coefficient, 3n squared. What happens to this negative 20n right here? What was the whole point of finding these? To substitute. We're going to replace them, okay? Doesn't matter the order that I put them in. No, okay? I'm just going to put minus 12n and minus 8n, and then I have that plus 32. So all I did was I took my 2 new factors and I substituted them in for negative 20n. Okay, so really, does this value change that value? No, it's the same thing. Okay, what do we do once we get to this step? Nope. If we combine like terms, we would get right back to where we were. Remember grouping? Yep, group the first 2 and group the last 2. So these 2 are going to go together, and these 2 are going to go together. So now factor them both separately. What can I take out of the first? 3n. If I take out 3n, what's left? n minus 4. Okay. What can I take out of the second one? Should I take out a negative or a positive? Okay, why do I want to take out a negative 8? What was the whole goal at this point? Right, the parentheses should match. Does that happen? Yes, did we get them to match? Yep. So remember, the goal is to get these 2 to match. Now we have one more step. How do I rewrite my answer? We take n minus 4 and 3n minus 8. Yep. So we got our answers. We took what matched, and then we took what was left and combined those. Okay? Okay. All of us are on the right track and heading in the right direction. Okay? First step of factoring, what is it? See if you can take anything out. Can we? No. Step 2. Leading coefficient. Do we have one? Yep. What do we do with it? Yep. 5 times negative 16 is negative 80. Okay. Step 3. Multiply and add. Multiply to negative 80, add up to 2. What do you think? What? Are you meaning 10 and 8? Oh, yeah. 10 and negative 8. Good. What do we do once we have our factors? and we have a leading coefficient. How do we rewrite? Yep, so we keep our first term. We have 5m squared. Then we have minus 8m plus 10m. Again, doesn't matter what order you put those in. Does it matter? Could I have flipped the 10 and the 8 around? Yep, doesn't matter. Okay, what's next? Group them. So these two are grouped, and these two. What can I take out of the first? An m. Can I take anything else out? No. What's left? 5m minus 8. Okay, what can I take out of the second? 2. What's left? 5m minus 8. How can you check yourself at this point? What should happen? These two should be the same, which they are. Okay, so we keep the one that's the same. Where do we get the other one from? Yep, the what's left over. M plus 2. Done. Okay, there was one more thing to look for in factoring. You remember what it was? First, can we take anything out of 68, can we? No. Is it a trinomial? No. So we don't think multiply and add anymore. So if we can't take anything out, it's not a trinomial, what do? What do you notice about both of these? They are odd, but no. Perfect squares. They're perfect squares. Okay? So, by perfect square, I mean we have to find the perfect square of both terms. So what's the perfect square of 9? 3. What about n squared? N. What's the perfect square of 5? 25. 5. Now, we have our perfect squares. How do we write our answer? I heard 3n minus 5. Yep, and 3n plus 5. So you write the same thing, but it just has opposite signs. Okay? When you have perfect squares, you find the perfect squares, and then you write them as a subtraction and as an addition. Okay. Why does the 3n have to go first? Why can the 5 not go first? Right, and because 9n squared came first. So we have to write the 3n first. Okay, let's look at 69. Step 1. Take anything out, can we? Step 2. Does that apply to any of those? Why? Because it's not a trinomial. Good, last resort. Perfect squares. Okay, what's the perfect square of m squared? M, perfect square of 9. 3, how do I write my answer? M minus 3 and m plus 3. Yep, awesome. Let's move on to 70 through 73. It says solve each equation by factoring. Okay. In order to solve the equations, what do we have to have them equal to? Yep, you must have them equal to 0 in order to solve. So on 70, are we good? Yeah. It's equal to 0, okay? Notice how it says solve by factoring. So obviously we're going to factor. So step 1 is what? See if you can take anything out. Can you? No. Step 2. Leading coefficient. Do we have one? No. Yes. Okay. Step 3. Add, multiply. What multiplies to negative 8 and adds up to negative 2? 4 and 2. Which one needs to change? Yep, negative 4. How do I rewrite? X minus 4, x plus 2. Remember, we're solving now, so it's equal to 0. How do we solve it from here? Yep, treat them as their own. So I have x minus 4 equals 0, and I have x plus 2 equals 0. Now solve both of those. So on this one, I add 4 on both sides. X equals 4. Again, how many answers should you always have? 2. X equals negative 2. So we got x equals 4 and x equals negative 2. 71, is it equal to 0? Yes, so we don't have to move anything around. Now we do the whole factoring, okay? So what multiplies to negative 42 and adds up to negative 1? Does that add up to negative 1? So we have 6 and 7. Which one needs to change? The 7. Yep. Because negative 7 plus 6 gives us our negative 1. How do I rewrite? N plus 6, n minus 7. And then again, how do I solve? Yep. N plus 6 equals 0. N minus 7 equals 0. What do you get for your final n values? Yep, n equals negative 6 and n equals 7. Okay, let's look at 72. What's wrong with this one? It's not equal to 0. How do we change that? Yep, subtract 3 on both sides. So I have x squared plus 3x minus 40 equal to 0. Now can we factor? Yes. So what multiplies to negative 40 and adds up to 3? 8 and 5, and which one needs to be negative? The 5. Yep. Again, how do we rewrite? Yep, x plus 8, x minus 5. Next. Treat them as individuals. Ooh. What do you get for your final x values? Yep, x equals negative 8. And x equals 5. Okay. Do you want to do 73 together? No? I see a lot of head shakes. Okay. Any questions over any of the review?